Okay, so for our example today, I'm going to make a Tesla coil. This should be rather fun. So I'm going to make a new folder, call it Tesla coil. And I'm going to add in a new code. So right click, new code, and I'll call that Tesla coil. Oh, my phone's ringing. Rightio, sorry about that. I'm back. So I'm making my code, and we're going to go into the code and we're going to make a class called Tesla coil. And that class is going to inherit from game obj. Public, private. We'll just fill in all the things you need to fill in. Okay, so now we've got an empty class, basically. Now, the first thing you need, if we look at GameObj, is this create function. Very, very important. Let's go to our Tesla coil, and let's make that function void create GameObj params, and a reference to obj, which will be automatically passed to the object. You don't need to worry about that. The next one is the update function, which returns a boolean. Now, what this boolean is, it's very useful. If the update function returns true, it means the object wants to still exist. If it returns false, it means it wants to be deleted. So if you tell the update function to return false, the Esenthel's world manager will delete that object and remove it from the container, which is useful, say for example, for a pickup item. So, say you've got a pickup item and you want it to be removed from the world when the player runs over it, if you get my meaning. After that, we need a draw function, UINT, draw prepare. And we're going to want shadows, so let's do the shadow function. Prepare. So these functions are not my own, they're all taken straight from here. See, here's the draw prepare and draw shadow. It's not compulsory to inherit draw shadow. However, as you can see, it does nothing if you don't inherit it. Draw prepare is compulsory. All these ones that say equals null are compulsory. There's a few others that you will want, because they also equal null, is these ones here. And so we can copy them over. Where is our Tesla coil? And chuck them there. However, essentially our Tesla coil is going to be a static object. Of course, I don't want to inherit from this static object because I want to show you how to do this. So but for the sake of these functions, they're always going to be the same. The position, the matrix functions are always going to be the same. So I'm just going to copy those from another object that I have that is static. Where are they? Alrighty, so I'm just copy pasting these functions in here. Of course, they're pretty simple. To get the position, you return matrix.position, get the matrix, return the matrix scaled. You can set the position, yada yada yada. You get the point. So let us continue. Now, there's of course a few things that we're going to need here to make this work. Of course, these variables don't exist in GameObj. You have to make them yourself. So let's go back to the Tesla coil and let's make some of these compulsory things that you're going to need. Alternatively, if you don't even need a position, you could just make these empty or return like an identity matrix or a zeroed vector. It's really up to you how you go about that. So I've got my matrix. I've got a scaled matrix. So it's the matrix once you add a scaling factor. That's in case you scale it in the level editor. and that includes our position, so that'll do there for now. Now of course we're going to have a mesh, so we're going to need a mesh pointer. You don't want to have just a mesh. You want a mesh pointer because you don't want to waste space loading so many of the same mesh. You want to rather have a mesh that's stored in a cache that you can sort of just access via a pointer. Therefore, each object that uses that mesh will use the same mesh instead of making a copy of it every time. So when you first get a pointer, if it isn't saved in cache already, it'll load it in cache. So anyway, let's add that there. Mesh, we're going to need an actor. We're going to need a material. It's a material pointer. Actors aren't stored in caches, by the way. Material pointer, so material, actor, and we're also going to need a physics body. I forget what it's called. One sec. A physics body pointer. Oh, and a path obstacle, if you're wanting to include it in an object. So we get a physics body pointer, phys, I call it, so does Esenthel, and path obstacle. Alright, now something's probably going to pop up later that we need, but for now that will do. Okay, so let's just continue on and fill out the functions. I'm just going to make the constructor and destructor just empty for now, and we'll start with the create function. Void Tesla coil, oops, create. Now of course we're going to have parameters for this Tesla coil. Let's think of a few. We're going to want the Tesla coil to have a range. We're going to want the Tesla coil to have maybe a damage amount. What else? We're going to have a sort of a wait time in between each lightning strike, or a charge time. Float charge time. I think that'll do for now. So let's go, and first we need to make the object class for this in here. So let's go and make that object class. Don't worry where I'm putting it, I'm just putting it so it works with my game. You can put it anywhere you feel like it. We will add in an object class, and I'm going to call it obj Tesla coil. Let's open that up, and now we need our 3 floats to be represented here. I'm going to make it a constant. Of course you might want to add things like HP or something. I'm not going to do that in this case right now. I might do it later, but for the sake of this tutorial I'll try and keep it shorter. So we've got range, we'll make a new parameter, real as in float, damage, and charge time. So let's make the damage say 10. The range will make it 7 meters, and the charge time, let's make it 2 seconds. Alright, so that's that. We close that, and that's saved now. Now we need an object that's going to be our Tesla coil. I don't have a Tesla coil object right now, so we're just going to use some random model that our Tesla coil is going to be. So how about we make our Tesla coil let's just make it a barrel. It's a very highly realistic Tesla coil. It works out of a barrel. So we open up whatever object we import for our Tesla coil. I'll obviously do a proper one later, And in this class parameter here, we choose our Tesla coil object that we created, and we can set its stats. So we just set its default stats. I'm going to stick with the default stats. So that's ready. Now there's another thing that we need to do. We need a container for our object. This can be a little confusing at first, but you'll get there in the end. Oh, what the heck? Let's have a look. Where do I keep my containers? I keep my containers in my level manager. You can keep them wherever you want. They are actually global managers. So I've just decided to put it in this file. Here's all my game object containers. So you need to make a game object container for your Tesla coil. I'm going to put it with the stateful objects. So it's game obj_mem_x. And now what's the class name? The class name was Tesla coil. And then we give that container a name. I'm going to call it Tesla coils. Container all Tesla coils. So we've got a container for now, but now we have to declare that container as the container for all obj Tesla coils. So that's where just before we load our world, so don't worry about how I've done this with my level manager, but just remember, before you load your world with the game.world_new, you need to set these object types. And so how you do that is really simple. You go game.world.setObjType, and the name of our container was Tesla coils. There it is. And the name of our object class was obj_Tesla coil. Rightio. So now we're all set up. Now if I place this object in the scene, in my level editor, it will automatically put it there. So let's go back to our Tesla coil. Don't need those, don't need that. Objects, stateful objects, Tesla coil. And let's get to it. Where are our object parameters? There we go, we need those. Now the first thing you have to do is you have to get the object parameters. So we first got to check if the parameter is there. So if param, we want to point it to the param equals obj.findParam, and then we give whatever this parameter name is. So let's go range. So if it can find it, then we go, okay, so range equals par as float. Now if you see all these as functions, you can convert a param into any type, but you want to make sure that it matches up with whatever type you set. So if you set string as the type, you want to use as float. As text, sorry. If you set int as the type, integer, you want as int. It's pretty self-explanatory there. So because all of ours are floats, we're just going to use float for that. I like to just copy and paste these to make up the speed, range, damage, and charge time. And I like them to line up, because I do. It's just the way it is. So you better accept it. Damage and charge time. Alright, so now we should have got our parameters. Now usually what I like to do in the constructor is, just in case those parameters don't work, I set the defaults for the constructor. For performance, you should set these in an initialization list, but I couldn't be stuffed doing that right now, so I'm just going to initialize them in the constructor. So range by default equals 7, damage equals 10, and charge time equals 2 seconds. So that's just in case, for whatever reason, something goes wrong. And I'm going to chuck this fella here. Okay, so we've got our create function there. We're going to need a bit more than that, because of course we've got all this mesh, material, physics actor, blah 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 stuff. Now, there's one thing that I actually missed, is we're going to need a scale. Sorry, vec3 is actually a vec, just a vec in Esenthel. Okay, so we're going to need a scale. That's another thing we need. So, other things that you can get from the object parameter are parameters that are innate to the model that you put in there. So, for example, let's go to our barrel. Let's make sure it has a physics body. Yes, it does. It's nice and square. And it already has a material, so that's another parameter. It has a mesh. It has, in the world, it has a position and a scale, etc. We'll place one a bit later. And we need to get all of this stuff. So, the first thing we want to get is the scale. So we go scale equals obj, dot scale 3. Now that's returns a vector, so each vector scale, so x, y, and z scale. If you choose just scale, that just returns a float, which is like the overall scale. I think that only works if you scale it universally. Okay, so the next thing we want is our mesh. I mean, you don't have to do it in this order, but you can. You go obj.mesh, that's that. Material equals obj.material. As you can see, this is incredibly hard stuff. I mean, it might take a little while to get used to the whole concept of objects, but really, how it works in the end is pretty amazing, I think. This body pointer. Oh, sorry. Just phys equals obj.phys. Now we come to our lovely matrix, which we have here. Matrix equals obj.matrix final. Now this final matrix is the matrix of its position and orientation that you placed in the editor, whatever that was. Now of course you need the scaled matrix, which gets a bit trickier. Of course the normal matrix needs to be normalized as well, because a matrix is more of a orientation, except for the position. So we'll normalize that. Our scaled matrix, scaled matrix I called it, underscore matrix, so it equals the first matrix, and then what we do is we scale it. Dot scale on L scale. Now, so what does this mean? The scale on means you're scaling the original. If you look at a matrix has usually only got 3 parts to it. It's more of an orientation. It doesn't include position. So it has where the x-axis is facing the z-axis and the y-axis. However, that's a matrix. Where are we? Let's have a look at the matrix. That's a matrix 3. And you can see that the matrix class inherits from matrix 3 and it adds in a position. So in Esenthel, the matrix has a position as well. You don't want to scale the position. Now what the on does is it simply returns the matrix 3 without the position. It returns a reference to it, sorry. So what that will do is, you can see the scale on function. I can't find it, but anyway, it doesn't matter. Not going to waste too much time on that. What this does, the scale on function, and the L stands for local, because you're scaling in local space. You don't want to scale around the origin of the world by whatever the scale was that you got. So now you have the scaled matrix and you have the matrix, and now we're set to go to create the physics, the actor, sorry. So if phys, so that's basically checking if this phys value is a body. So for example, if you didn't set the body, the physics for the model, then it would not be, this would return false, and you wouldn't be able to